A river flows due south. A riverboat pilot heads the boat 297 degrees and is able to go straight across the river at 6 meters per second. What is the velocity of the current? What is the velocity of the boat? Let alpha is azimuth of the boat 296 degrees. Let V absolute is the velocity of the boat with respect to ground. V absolute equals 6 meters per second. We have to find the velocity of the current. V current velocity is a vector. And we have to find the velocity of the boat, VB. So first of all, let's show directions. Northern direction, southern direction, to the east, to the west. Now let's show the velocity of the boat. This velocity has bearing 297 degrees from the north. Like this. This is bearing alpha, clockwise from the north. Now we can use the formula for addition of velocities. Absolute velocity, in other words, the velocity with respect to ground, vector, is the sum of two velocities. Velocity of the boat with respect to water plus the velocity of the current with respect to ground. This is the velocity of the boat, V boat. We know that a riverboat pilot is able to go straight across the river, Current is directed to the south. Straight across the river means this direction. So we can show these vectors like this. Velocity of the current and absolute velocity. Now we know that V absolute is 6 meters per second, and as you can see, to the west. Let's use more convenient angle beta. Beta, as you can see, equals 360 degrees minus alpha. This angle is more convenient because this is an acute angle. The same angle is here because we have two parallel lines and transversal. And as you know, alternate interior angles between these two lines and transversal are equal. So this is beta also. Now we can use trigonometry. For example, in this right triangle, V absolute is opposite angle, opposite side of triangle, opposite leg, and VC is adjacent side. So we can write V absolute divided by V current equals tangent beta. We know V absolute and we have to find V current. So V current equals V absolute over tangent 360 minus alpha instead of beta. This is the speed of current. Now, the absolute divided by VB is opposite leg of right triangle divided by hypotenuse. So we can write V absolute over V both equals opposite to hypotenuse is sine of beta, and hence V both equals V absolute over sine of 360 degrees minus alpha. By the way, if you know reduction formulas, you can write the same in other way. For example, tangent of 300 degrees minus alpha equals minus tangent alpha. You can use also this formula and the same for sine. Sine 360 minus alpha equals minus sine alpha. But it seems to me that these two formulas are more convenient to use. And let us calculate numbers. 360 degrees minus alpha gives 63 degrees. So we can write VC equals V absolute 6 meters per second over tangent 60 degrees, 63 degree equals 6 over tangent 63 gives 3.05715 and so on. here we have two significant digits. So we must round this number to the same number of significant digits, to 2 digits. That's why we must write 3.15 meters per second. And the next, the velocity of the boat. The speed of the boat equals 6 meters per second divided by sine of 63 degrees gives 6 over sine 63 6.733957 and so on. When rounded to 2 significant digits, we must write 6.7 meters per second. So the answer is V current equals 3.1 meters per second to the south. V boat vector velocity 6.7 meters per second and direction is on bearing alpha, on azimuth alpha. 297 degrees. The problem is solved.